This is about stem and leaf plots. The stem and leaf plot has its name because it sort of resembles what we see in nature with a part of a shrub or a tree, and basically we've got stems and leaves, and so you've got something that goes sort of straight or relatively straight as the main thing, and then we've got things that come off the side like the leaves. Okay, so trees, shrubs, branches have that same sort of structure, so that's why it's called stem and leaf plot. It's a type of graphical display. We can learn about stem and leaf plots, or stem plots for short, by looking at an example. And we have a data set here. You can see that it's surrounded with a thick green line, and I've already put them in order, so if they're not in order you may need to do this yourself. So what we've got is a stem and leaf plot uses obviously a stem and leaves in the structure here. And you can see what we've done is take the numbers from all of these numbers from up here and put them in the stem and leaf plot. How does it work? Well, one way we can do that is to look at what's called the key, and the key tells you how the plot should be read. So you can see right down the bottom is the key. So for example, a key is an example, and if you had a 2 on the left of this big long line here and a 4 on the right hand side, that would mean 24. So that's how you read it. So that's an example. And we look at not just the numbers in there, but we look at the shape. Alright, now this one here has this sort of shape. You might remember a thing called a histogram, and it's got bunches of columns on it, and we can join the sort of middle of the columns together and you can get a shape. This one here, for example, would be that the green line gives the shape, whereas this one here's got this sort of shape. And the shape is important. It tells us how the data is spread. So if you haven't worked it out already, we put these numbers in by going, well, the first number here is 12, and that would be 1 on the left and 2 on the right. Next number is 16, which would be again that same 1 and a 6. Don't repeat the 1. So anything in the 20s will go on this row here, and we've got 22, 23, 24, 27, 22, 23, 24, 27, and so on until we finish with all the numbers. A variation on what we can have is called back-to-back stem and leaf plots, which are more useful because they compare two sets of data together. And when we're comparing data using a back-to-back stem and leaf plot, we can see the differences in the shapes and the skew. So what you do is they have the stem is shared, but the leaves are in opposing directions. And so we've got here scores for the last 30 football games. So we have a key, 10 on the left and 9 on the right means 109. So this stem column is the tens, alright? So 70s go along here, and for the other side it goes along there. So for the first one in the 70s on the losing scores is 74. There aren't any 70s at all on the winning scores. In the 80s, the first one for the losing scores is 80, and the first one for the winning scores is 81, etc. We can see a bunch of features on here too. You can see them pointed out. Okay, I'm just going to clean this up. Alright, now for the winning score, the lowest score is 81, and for the losing score, the lowest score is 74. The winning scores are higher on average than the losing scores. You you could do a calculation like the mean for that, but you can see that they are because they're further down that way. These ones are further up that way. We would call this one here symmetrical because it creates a nice symmetrical curve. If I turn that curve, if I rotated that curve, it would look like that, and that's pretty close to symmetrical. Symmetrical in statistics doesn't mean exactly symmetrical, it means pretty close to symmetrical. Whereas this side here, on the right side, it's skewed. I'll use yellow. So with the skewed one, we don't have the symmetry on that curve, we have what's called a tail. And the tail points downwards. Alright, so if I was to rotate that, you would have this sort of thing. And that's not symmetrical. So it's got a tail, it's skewed. And that one would be called skewed to the top end because it's got its tail points up to the higher numbers. Alright, so that's the difference between symmetrical data and skewed data, and stem and leaf plot can show us those two main shapes. Let's look at an example here. This one's a little bit different because we're not looking at units and tens, we're looking at units and tenths. Alright, we have decimals in other words. So we've got some instructions here. We have to organise the data into a stem and leaf plot, then find the median, the mode, and describe whether it's symmetrical or skewed. So we have 4 things here. So I've included the stem and leaf plot here just to save a bit of time. But you can see that the lowest number there is 0.1. There's 2 of them. There's 0.1 there and another one there. And you can see that they're down here because if we look at the key, this key works differently. So you don't have to have the key working the same way every time. It's more convenient for the key to work like this. 3 on the left and 4 on the right would mean 3.4. So the stem is the units in this one and the leaves are the tenths. So that'd be 0.1, another 0.1, a 0.3, right up to 7.5. So this is not a back-to-back, it's just a regular stem plot. Now we can use these to find the median. We have to find the middle of the data, and basically that once it's in ascending order, and that will tell us whether it's which is the median. So how many bits of data are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8. There are 28. So what you do to find where the median is, you go n plus 1 over 2 will tell you the location of the median. Now there was 28 numbers, so n is 28, and add 1, which is 29, and 29 over 2 is 14.5. So it's in the 14.5 position. 14.5, what does that mean? Well, it's between, that really means between the 14th and the 15th position, okay? So we have to find that. So the 14th and the 15th are 3.3 and 3.4. So we have to find what's halfway between 3.3 and 3.4. So you find the mean of those two, or the average, or the halfway mark, and that would be 3.35. So the median is 3.35, right there. Okay, and the mode is the most commonly occurring. Well, if you have a look on there, there are 3 of these, and that's more than anything else. That number is 4.1. So the 4.1 occurs the most often. It's the mode. And is it skewed or is it symmetrical? Let's have a look at the shape. So it starts off pretty high and hits a peak and it comes down. So it's not really very good either way, but it's a little bit of a grey one, but it's a little bit skewed down that way. But I would say the best one to choose would be symmetrical. So sometimes in statistics, you've just got to make a bit of a decision and be able to defend it. And I would call that symmetrical, but not, certainly not perfectly symmetrical. It's a tiny bit skewed, but it's probably better as symmetrical. Try some.